Hi, welcome back. I'm Julian at Just Inspired. Thanks for joining me. And let's fix something. Right, this humongous thing with a very scary looking capacitor on it. Right, I have no idea what this is for, some sort of industrial equipment. And I said I don't think I'll be able to do anything. I'll have a look and see, because there's a blown component on it. That capacitor is... oh, it's only 16 volts. It looked super scary. 27,000 microfarads. Poof. That's a big microfarads. Oh, there's a 450 volt capacitor there. Yeah, no thanks. So we have some sort of power supply here. Bunch of relays. Some microcontrollers. SD card. 8 gigs. Looks expensive, whatever it is. Very expensive. Now let's have a look at let's make sure that mains capacitor is discharged. Nothing in that, I don't think. Okay. This one I got from AliExpress. I can leave a link for you in the description if you like. Let's just double check that. Voltage DC and 0.3 volts. Yeah, fine, cool. Right, so this one we have a blown IC. And it is here. That is proper cooked. IC41. It is cooked. Let's clean it and see if we can see any better what it is. I think that is proper gone. I think it is not readable. Yeah, that whole top piece has come off. It's just charcoal. That doesn't look too good either, that one. No idea. No idea. Looks like is that a double diode or an optocoupler? Probably an opto. Bunch of them there as well. That's a bridge rectifier. Just inspired, can I help you? Hiya. No worries. Yeah. yeah. In hindsight, it wasn't such a good idea. So. Okay. Right, let me have a look on the old drive. I'm sure I transferred everything across. We went through piece by piece. Let me have a look on the old drive and see if I can locate them. Yeah? Alright, no worries. Okay, great. Yeah. Alright. I'll get back to you. Alright, cheers then. Bye. Right, now he did say that he sent me a picture of another board that may be able to see what that component has got on it. So let's see if I can find that picture. Right, it's not a great picture. $5422603A. Kind of looks like a Texas Instruments logo. P2 something KX. Yeah, that's not a great picture. So that says P2K something 4 at the end. If I look at this one, looks like a G4, but that one definitely looks like a P3, not P2. Alright, let's check the first number.
Later.
Right, so looking at the pinout, we have ground here on pin 5, and we have voltage coming in on pin 8. So let's take a look at this here. So let's verify that by checking that pin 5 is actually grounds, and pin 5 should be this one. Pin 1 should be up here because you've got a chamfered edge on the chip. So pin 1 would normally be on that chamfered edge where it's got that 45-degree angle. Right, so that's ground, and let's find the capacitor grounds. Yeah, that's a direct path. Okay. Check the voltage coming in, see if we've got a short there. No, we do not. That's definitely voltage coming in. So this side of the capacitor here must be ground, which it is. Right, okay. So what I shall do, in order not to skew any readings, I shall remove the chip from the boards. And to do that, I'm going to use some low melt solder, I think. I've got some of this fast chip. Come on, focus. Lead-free alloy. And it comes in these pre-cut and pre-formed lengths. And I also bought some nano clear flux from Mechanic, which I've never tried before, so worth a try. So let's get back to the microscope. Okay. It's quite viscous, this one. Put the soldering station back on. Right, fume extractor on. See, that has welded itself to the track. Okay, let's get the solder off of there. Yeah, that pad got welded, so we'll need to fix that with a little jumper when we put the new part in. Turn off the fume extractor. Okay, clean it up. I'm using a camera lens duster for this, JJC. So basically it doesn't pull any air in through the tip of the nozzle, only through the back. So it only blasts out the bottom and pulls in air from the top, which is pretty cool. Works very well. Right, I shall let him know what I have found, but before that let me just take some measurements. So what is the output pin? Right, so I want to check downstream from the output to see if that is shorted. Checking on here, which one is the output? Pin 3. Right, so I need to be in continuity mode. Continuity. Right, so we established that that is ground. This pad got welded to the chip, so it tore off when I removed the chip. That's where all the damage was up this end. So if that's pin 1 here, oh, sorry, you can't see what I'm talking about. Right, so pin 8 is where the power comes in. That's the one that got torn because it was welded to the pad, and that got torn off when I removed the chip. So that's ground, that's pin 5. So pin 3 is this one, so let's see if that's got a short. We have no short there. On the output, let me go into resistance mode. So we go from 3 to ground. Nothing there. Okay, so not active when enable pin is low. So when we have no voltage at the enable pin, that's not on. So let's check between ground and the enable. "12 kiloohms, that's fine. Number 2 is a feedback unit, or feedback input rather. So between ground and there, 9K, 5 is ground, 6 is a switch node connection between high side N FET and low side N FET. So that would be that one there. 2.1K, so it doesn't look like we've got any shorts on this. Voltage in on pin 8. No, I can't see any shorts there, so let's go back to ground. Check one of these capacitors. 2K. Right, let's go into diode mode. I'll check a few things. That's a capacitor, safety capacitor. Back to diode mode. I want to check this transistor or whatever the hell it is. That's showing a short. That's not. Okay, so both that diode and that transistor have a short across. IC11. Let's see what that is.
Moments later.
Power ICs for switching power supplies, incorporating a MOSFET and a quasi-resonant control IC. Yeah, I didn't realise there's loads of pins behind it, so yeah, that's an IC. I'm probably not going to measure it properly. Right, let's pop the Xena diode out just to check that it isn't shorted. Right, now let's measure that. I'll pull you forward a bit. Nothing that side. So the shortage reading is not across the diodes. Some more diodes we can check. Well, so far it's only looking like that voltage regulator's gone. But with a complex board like this, there could be other things wrong. Let's give that a little clean up. Got another diode looking thing here with a heat sink. Yep, that looks okay. Fuses are good. Right, let's see if we can order that voltage regulator. So I found out that this board belongs to a Mitsubishi heat exchange unit, heat pump. And it is the flow control board. Mitsubishi. Yeah, not cheap. So if I get like 5 of them. Yeah, that's the problem with these things. It's always expensive to buy them because you only need one and you got to pay shipping, which is more than the price of the actual thing you're buying. Anyway, I'm going to get 5 of them in case we get any more boards like that, because if this works then chances are we should get more and they probably will have the same problem. If that's a common failure point. Check out £19. Oh. Crazy. Shush.
Three days later.
Right, brand new day, and we have the parts for this board. Well, the part. So let's get under the microscope and do some soldering. Right, let's put a little flux down on that. I'm going to put a little flux on here to help the solder flow. We're going to have to make a little jumper from one leg to this pad over here, this trace. Might solder it to the capacitor there. Right, so let's solder just one pad, like that. Where are you going? I think we should be able to just solder blob that one there. I don't think we need a wire. Nice. We've got it the right way around, yep. Pin one's up the top left. Ground is down the bottom right. Cleanup time. Use a little bit of isopropyl alcohol here. Right, that looks very good. Right, I did want to check that resistor. The resistor on pin 2. Uh, 9.2K. Yeah. This one. $40, yeah. Just to make sure we have no shorts. So ground is here. These are not grounded. No shorts. Very good. So apparently what's happened was up this line they accidentally sent some voltage, I think it was a 12 volts, and it didn't like it. Well, hopefully that does it. I can't find anything else. I can't find anything else wrong on the circuit board, so I'm just going to give it back to them and hope for the best. So I really don't have any means of testing this, so I shall just wait for the customer to tell me if it works or not. A lot of times these things are just gotta wait and see. So anyway, that's another job done. Let's get that back in the bag and you can come and collect.
Several days later.
Well, I have some good news today. The customer called me and said that it's working perfectly. So yeah, result. So thank you very much for joining me. I'm very happy I was able to help this customer. And I won't ask you to like or subscribe or anything like that. So I'll see you in the next one. Bye.